Alright guys, we're going to do 8.2 today. So we're going to start with the definition of sample proportion. So the sample proportion, noted p hat, is given by the formula x by n. And then what we're going to do essentially is take a whole bunch of samples and then calculate all the proportions and then draw the bell curve, and we'll notice the sampling distribution of sample proportion is normal. So the mean for that distribution is p. Standard deviation is p1 minus p over n. And we'll start with the mean, 0.09. Sample size for part A is 5,000. So we're going to do 0.09. 1 minus 0.09. Divide by 1,000. Excuse me, 5,000. And we get 0.0040. And then we'll do the mean, again, 0.09. And then we change sample size to 1,000. So we come over here and change sample size to 1,000. And we get 0.009. And I'm not going to do every single piece because part C is just a repetition. So I'm going to carry on to the next question. Sampling distribution, mean is 0.3, always proportion. Standard deviation, 623 sample size. 0.3, 623, 0.184. Again, same thing here, just change mean this time. I'll do this one more for you, 0.6, and then we'll change to get the new standard deviation. .0196. Okay, so you can do the last part. Again, same thing over and over and over again here. So 0.4, sample size of 200. So 0.4, 200, 0.35. All right, so again, 34% do not own a credit card. That's the mean, always percent. Standard deviation we'll get with the sample size here. I believe it was 400 there. Yeah, 400. So we get 0.237. Which will be 0.24. Now we can do probability questions. So we take the mean and standard deviation and put it into the normal calculator. So the mean, 0.34, standard deviation. Here you want to go as many decimals as you can. Or not as, but quite a few. So let me jot this down. 0, 2, 3, 6, 8, 5. So I'm going to go this many. 0.023685. And then we want to know more than 36%. So we'll just do greater than 36%. And we get 1992. And then out of 100, we would expect 20. So just multiply 100 by the probability. We get 20. And then between 31 and 36. So between 31, 36, 6981. And then out of 100, we would expect 70. And then 124 out of 400 or fewer. So here we have to convert 124 out of 400. Which is fewer than 31%. Fewer than 31%. 1026, which is not unusual. Because the probability is greater than 5%. All right, so we'll do another example here. Got exit poll example. So here we've got 200 voters, finds 102 voted for the referendum. So how likely are the results of your sample if the population proportion of voters in the town in favor of the referendum is 49%? So 49, that's our current population proportion, that's our mean. And then sample size is 200. So we can get our standard deviation. Standard deviation 0, 3, 5, 3, 4, 8. And I'm just going to go one more here. So more than 102, again, we've got to convert that to a percentage. So let's do more than 102 out of the 200, which is more than 51%. More than 51. And change our mean, of course. 49. What is the mean? Standard deviation. 0.3534, 83. Again, go as many as you can, or at least 5 or 6 here. Sometimes my math lab is picky about that. So we get 2858. And this is not unusual, so we're going to do either B or C, because the probability is greater than 5%. So it's going to be that one. All right, again, we've got 76% of the people are satisfied with the way things are going in their lives. Random sample is 100, so 0.76 and 100. Now we can get our mean and standard deviation, or standard deviation. Already got the mean, so 0.76. So let's jot that down. 0.427083. And we wanted exceeds 80%. So the mean 6. Standard deviation 0.427. 0.427. 0.83. And exceeds 80%. So greater than 80%. 1745. And then out of 100 people, reveal 70 or fewer. Well, that's less than 70%. so less than 70%. 0.08. 0.08, which is not unusual because the probability is not less than 5%. All right, and a fingerprint expert will correctly identify a match 81% of the time. Forensic database of 1,100 different pairs, that's our sample size. What proportion of the 1,100 pairs would the expert expected to correctly identify as a match? Well, that's given here, that's just 81% of the time. And then here we've got to do 935 over the 1,100 to get that sample proportion p-hat. So let's jot down 8.1 and our sample size 1,100, and we'll get our standard deviation. Standard deviation 0.118283. Mean standard deviation and 935 over 1,100 is 85%. And it was do 935. It was fewer than. So fewer than 85%. And get our standard deviation here. 0.011823. 9996. All right, mean again, straight away, 0.2, standard deviation over sample size, so it's 5,150. So 0.2, 0.2, 150. Standard deviation 0.32659.8. 0.2. Get our standard deviation. 0.0326598. And then what probability are they wanting here? Oh, well, 6 decimals here. So let's go ahead and put that in. 0.3265. Oh, that'd be 66. And then greater than 26%. So greater than 26% is 0.331. And then less than 16%. 1103. All right, and got a couple more here. So the mean, again, 5%, that's P, 5, the proportion of people who leave their jobs to retire. And then standard deviation, so let's jot down 5, and our sample is 1,000. So let's get standard deviation here. 0.05. 1 minus 0.05 over 1,000 standard deviation here, 02179.449. Oh, 179.449. And going here to fours, which would be 0218. Make sure you round correctly. And now we'll do less than 7%. 8206. And the way we interpret this on the interpretation is if a random sample of 1,000 workers has a proportion which is less than, is always equal to this calculated probability. And then we'll do greater than 0.037. So greater than 0.037, 7246. And the proportion is greater than, is equal to the calculated probability. .037, did we do 037? 7246. Sometimes if you, sometimes this question may be a little bit strange on the rounding. Let's see if we go down to here. 724, so we still get 7246. Seven two five four. Let's see, 02179. 7246. I tell you what, let's use all, let's see what we get if we use them all here. We get 7245, we still get 7246. So let's try 7254, let's try 7254. See what we get. 7254. 7254. Okay, I'm going to go with, again, I'm going to go with the most decimals here. And let me double check. 0.037. And we did greater than 0.037. So 7246. So let's go with 7246. 7246. 7246. Let's see. Did we do this standard deviation correctly? 05 and 1000. Let's double check that. Oh, that's what it was. That changes the standard deviation. Let's do, I left off, instead of 100 here, I put 1000. So let's do another question here. It was 100 and not 1000. So let's go back up here and do a quick similar question. So now we've got 4% and 950. So be real careful here, 4% and 950. So let's jot that down. 0.0064886, and that should be plenty. 4%. Sorry. 4%, 1 minus, okay, so let's jot this down, 0.00635. 776. All right. So mean 0.04. Standard deviation 4 decimals 0.0064. Less than 6%. Again, I'll just use all these here. Standard deviation less than 6%. 9992. All right, and the probability that a random sample proportion less than equal to, and then greater than 0.027. 0.027. 9796. 9796. And that is portion greater than is equal to calculated probability. All right, so again, what threw me off on the previous question was just the sample size there. So be careful when you're doing that, and then we'll finish out the last one here. So we've got mean is 4,4, and sample size is 1,000. So let's do 4,4. And 1,000. So it's 0.15. Let's jot this down. 0.15697. So we got here. And then more than 460, again, you got to do 460 out of the 1,000, which is more than 46%. So let's go put in our mean, our standard deviation. 0.1 5697. And then more than 46%, which is 1013. And then less than 410 would be less than 41%. Less than 41%, which is 0279, which would be 03.023, 0.028, 0.028. Okay, so that's the 11 questions, and I hope this helps, and I'll see you on the next video.